The Hello, and welcome to a Forge Cinema's visual effects tutorial. I'm Garrett Kerr, and today I'll be teaching you how to do a simple voronoi fracture in Houdini. So, to start this project off, what you're going to want to do is pick out some geometry that you'd like to fracture. Houdini comes preloaded with some test geometry that you can use if you don't have your own model, but I have brought in my own model. It's a vase or an urn from one of my own projects. And I think that it'll work well for this destruction here. So after using a file import node to bring in my geometry, I brought in a clean node just to make sure that it didn't have any bad geometry. There weren't any polygons that were disconnected, no vertices missing. There wasn't anything that was an ingon, so that had too many vertices. It's topologized cleanly so that Houdini will know how to fracture it later once we get further down the tree. Then I transformed it and brought it into place for where I wanted to have the object destroy. Sorry, it takes a second for my laptop to load sometimes. I'm on my computer at home, which isn't the strongest. So there, it took a second to load the transform node. But here I just brought the vase or urn, just a second, so that it would be floating directly above our origin. And that way it'll just be able to fall straight down into the middle of our scene. Following that, I subdivided it just to give it more polygons to fracture into. This will make it have more options for the scatter node that we're about to put on so that we can get higher detail on our fracture sim. So now we have our geometry that's ready to be fractured. So after you decide how much you want this subdivided, how small you want your fractures to be, then you're pretty much ready to start scattering points onto your object. And with those scattered points, then you can have your object decide where to fracture from there. So now that we have our geometry, you can make a VDB from VDB from polygons node, and that will convert your polygons into voxels, which is volume pixels. So it just gives a little bit of shape and form to those polygons. And then following that, I put down the scatter node that I mentioned earlier, which just a second my laptop will show you. There we go. Okay, so here, when I have the scatter node shown, you can see a bunch of tiny dots where the vase or urn should be. And those are all little points that got scattered onto the vase. And those are points that will decide all of the little fracture pieces. Those will, through some settings that we can change, those will decide the size and shape of our pieces. So here we've got some options. This number is what changes how many points you're going to scatter onto your object. The more you have, obviously, the smaller the fracture shards can be. If you only have 2 points, it's not going to split up that much. It'll just be 2 separate pieces. So the more you have, the more fractures you'll get. However, that will make your sim more expensive to run on your computer. So if you have a weak GPU or CPU, then you might not want to run complex simulations. So after we've decided how many points we want to scatter onto our object, you can use the point jitter node. Okay, sorry about that. I went into my settings and changed the uh, pixels into points so that they'd be easier to visualize. So here we can take another look at the scatter. You can see that these points are showing up a little bit better now. Um, and then in the point jitter node, in just a minute, there in the point jitter node, you can see that all of the points just get spread out and you no longer have the shape of your object um, because these go outside of the geometry that you have set, but it is just like another way to randomize the fracture that you're going to see on your object. So you can change these numbers around to scale it up. Uh, you can scale it down. You can change the axes. That's the main thing that I've done with mine is I changed the axes scale so that that way it is spread out more this way on the x-axis than it is on the y-axis, so that we would get more of a fracture in that direction. And then we can go to our glue cluster, and this is just another way that we can play with our fracture. So let's say you have a bunch of tiny fractures and you want to keep some tiny fractures, but not all of them. Well, the glue cluster is a great way to just clump up some of your pieces so that they don't fall apart from each other. So you can see here, there's all these colored dots. And if you see any colored dots of the same color that are close to each other, that means that there's a cluster of glue holding those points together. And that's just a way to, through changing these settings, to change the size of your pieces, but not just in a uniform way. So this lets you have more precise control over different parts of your fracture just by changing these numbers. So like you can change the size and then have it be in one direction, um, rather large for this number, and then take it down a notch and have it be smaller so that you can have larger pieces breaking in certain directions and smaller fractures coming from a different direction. After that, you can finally put in your Voronoi fracture node, and you're going to want to have your original geometry go into the left input, and then all of the points that we made from your VDB from polygons and scatter and point jitter and glue cluster go into the middle input. And then let's see what this looks like with our Voronoi fracture being visible. So you can see some cracked lines on the side. There's a bunch of fractures all over it. See how some of the pieces are bigger than others very clearly. Here you can see this one smaller piece right next to a few bigger ones. So I just played around with the glue cluster and the point jitter and my scatter until I found something that I liked and had a few small pieces here and there, but obviously nothing just completely breaks down to dust when it hits the ground, so I didn't want to have the whole thing end up in tiny pieces. But we're trying to make it as realistic as possible, so it is likely that some smaller pieces would scatter. So after you have this node put in, you can choose cluster, and obviously there's cut, interior detail, groups, and attributes as well that you'd want to worry about. But for this, my computer doesn't have the performance to run interior detail, so I've only changed a little bit of the cluster. If you want more tiny fractures to come off the inside of your geometry, you can add interior detail, and it will make your render time take longer, but you will get a much more realistic fracture with a bunch of tiny pieces coming off here and there depending on the size of your object, some of them might even be so small as to be like particles. But you'd want to mess with your interior detail only if you're sure that your computer can run it. If I were to turn it on now, I'm almost positive that it would cause my Houdini to crash, so I'll have to stay away from there. But if your computers can run it, I would definitely recommend including interior detail on your fractures. It'll make them look a lot cleaner. And here I threw in an exploded view node just so that we all could see what this looks like before it's fractured, but this way we can get a good look at all the pieces before actually running the sim. So you can see a lot of my pieces are pretty close in size, but then I get some smaller ones. Like over here we have something sticking out, and then there's a few chips down here from the top. These pieces are a little bit smaller than the rest. So you can see that like there is a variety in piece size. It's not just all uniform, which is really what you want. You just want for things to not look so manufactured. You're trying to make stuff look as organic as possible when you're doing visual effects. You're just trying to make it look like it would out in the real world, but obviously that can be a tricky task for students to handle. So it's going to take a lot of practice, and you'll just have to play around with the different settings on your fractures until you can get something that you find looks realistic. And don't be afraid to use reference videos to help guide what your fractures should look like. For this, I found reference images of vases breaking and pots shattering before I even tried to decide what the pieces would look like. And that's just a good habit to get into for all of the beginning VFX students. Just use real life references because that's what you're really trying to do when you create visual effects. Unless it's like some fancy sci-fi scene that you're working on, you're just trying to make stuff look as believable as possible that it could be real. So I'd fully recommend using real life references to help guide your projects. But now that we have everything set up for it to actually fracture, let's take a look at the video and see what it'll actually look like after we get fractured. So now that we have our flipbook rendered out, we can see what this fracture actually looks like. Let's go take a peek. And you might be able to notice the dust in the middle there. I did add in some dust on my own, just as a fun part of this project. But mostly here we want to focus on the fractures. I added in a little coloration so you can see the different pieces that are actually breaking off more easily. This kind of shows what they're divided up by, and they stick out more against the gray ground plane more. So yeah, that's how you can run a standard Voronoi fracture. And thank you for watching, and tune in for our other tutorials to learn more about visual effects.